Section 1.8 is about combinations of functions, and this also composite functions. That's hard for me to say, apparently. So functions are quantifiable. In other words, we can count functions. So they're quantifiable objects, and therefore can be expressed by either abstract, like variables, or discrete, numeric amounts. And as a result, we can work with them just like we would with numbers and variables. So as an end result of this concept, what we can take is two functions, in this case f of x equals 2x minus 3, and g of x equals x squared minus 1. We can add, subtract, multiply, and even divide them. So let's give this a shot. F plus g of x. I'm going to color code this a second. So for f, let's do that in red. And then g, green starts with the letter G, so we're going to go with green. So f plus g of x. Now this notation is kind of goofy. What I want you to think about when you're doing this is it's really f of x plus g of x. So we're literally just going to take those two pieces. So f of x was, let's see, 2x minus 3. That's one group. And I'm going to put them in parentheses. It's going to become more important later. So f of x is 2x plus 3 plus, and we're going to add g of x squared minus 1. Now this is all one big group now. It's like we have one group plus another group. We can combine like terms as needed, but let's kind of start in order. So the highest degree we have here is x squared. So let me actually switch to a neutral color. So we have x squared. Moving on down the line, 2x is the next highest, so we got plus 2x. And then our common constants, we have a negative 3 and a negative 1. When we add those two together, we end up with negative 4. So we'll say f plus g of x equals x squared plus 2x minus 4. We're going to try the same thing, but instead of adding the two together, we're going to subtract them. So we'll do f minus g of x. So we'll do f of x and then subtract g of x from it. So it's going to be the same format that we had before, 2x minus 3. But instead of plus g of x, we'll do minus x squared minus 1. Now there's a couple different ways you can go about this. I know some people like to distribute the negative two things in the other group, and I think that's probably something that might come in handy here. So that way when we start doing that, we'll have 2x minus 3 minus x squared, and then minus negative 1 ends up being a plus 1. So if it helps you to distribute that so that way you don't have to worry about parentheses, awesome, go ahead. Now I'm just going to go through and put this in order. So the highest degree term we have is the negative x squared. Then we have 2x. And then the only like terms now we have are negative 3, and in this case, plus 1. So negative 3 plus 1 is negative 2. So we'll say f minus g of x equals negative x squared plus 2x minus 2. Next up, that one looks like f times g. So what we're going to do is we're going to take f of x and multiply it by g of x. So f of x is the whole group, 2x minus 3. And we're going to multiply that by the whole group of x squared minus 1. In order to multiply those two groups, we're going to have to distribute. So 2x gets multiplied by x squared. We got 2x to the third. 2x times negative 1 gives us negative 2x. Negative 3 times x squared is negative 3x squared. And negative 3 times negative 1 gives us positive 3. So we got to do every term in one group times every term in the next. Sometimes you'll hear the word for something set up like this as FOIL, first, outer, inner, last. But I'm just going to talk about distribution because sometimes you have more than two terms per group. Cleaning this up a little bit, we're going to do the highest degree term, 2x to the third. Then our next highest is minus 3x squared, then minus 2x plus 3. So we're going to say f g of x equals 2x to the third minus 3x squared plus, or minus 2x plus 3. Lots of 2's and 3's there. Okay. F over g, it's a division. So what we're going to do is we're going to take function f of x, and divide it by function g. So f of x was 2x minus 3. G of x is x squared minus 1. That's it. Like, we can't simplify, we can't divide it. What we could do to kind of test this out, if you wanted to do, say, f, I'm going to do this in blue. If you want to do f over g of, let's pick a number 2. It would be the same as f of 2 over g of 2. So in other words, we'd have 2 times 2 minus 3 over 2 squared minus 1. So we'd have 4 minus 3 over 4 minus 1, which would give us 1 over 3. So just kind of a way to format these things, how to plug these into the various setups.